Hello friends, welcome to my YouTube channel. This is the 11th video of Data Science playlist. Today's topic is logistic regression. Logistic regression is a statistic method used for binary classification tasks where the goal is to predict a categorical outcome with two possible classes. It will be yes, no, spam or not spam. Despite its name logistic regression, it is used for classification, not regression. Logistic regression predicts the probability of an instant belonging to a particular class. The output is probability between 0 to 1, which is typically mapped between the binary class level using a threshold often 0.5. Logistic function sigmoid. The core of logistic regression is sigmoid function, which maps the real value number into a range 0 to 1. The sigmoid function is defined as sigma equal to 1 upon 1 plus e to the power minus z. The cost function. Cost function is the goal of logistic regression is find best fitting parameters that minimize the cost function, which measures the difference between the predicted probabilities and the actual labels. The cost function used in logistic regression is the log loss or binary cross entropy. Optimization. The model uses gradient descent and Newton's method to the minimize cost function by adjusting coefficient iteratively. Explanation about logistic regression. The data preparation. The data sets consist of features like feature 1, feature 2, and a binary target label. We split the data into training and testing using model training. We initialize a logistic regression model with logistic regression. The model is trained on the training data using model.fit x underscore train y underscore train. So we'll move to the next slide. Next slide is understanding the logistic regression equation. Welcome. This presentation explores the logistic regression, a fundamental technique in the statistic modeling. We will delve into the application, interpretation, evaluation, highlighting the advantage and the key concept beyond the powerful tool. Understanding the logistic regression equation. The core equation. Logistic regression predicts the probability of binary outcome using a sigmoid function to transform a linear combination of predictor variables. The equation takes form of the equation you can see in the PPT where P represent the predicted probability. Sigmoid function. The sigmoid function S shaped maps any input value to a probability between 0 to 1. It ensures that the model's output is always valid probability. The function has a steep slope near the middle, making it sensitive to changes in input values. Assumption and diagnostics for logistic regression. First, linearity. The relationship between the predictor variables and the log odds of the outcome should be the linear. This assumption can be checked using the scatter plots and residue analysis. Second is independence. Observation should be independent of each other. Assertion can be violated if there are repeated measures or if the observations are clustered. Third is multicollinearity. Predictor variables should not be highly correlated with each other. This assumption can be checked using the variation inflation factors. Next is performing logistic regression in R and Python. Example in R you can see on the PPT and example on the Python you can see on the PPT. Next is interpreting logistic regression results. Coefficient. Coefficient indicate the change in the log odds of the outcome for a unit increase in the predictor variable. Positive coefficient indicate a positive association while negative coefficient indicate the negative association. Odd ratios. Odd ratios represent the change in the odds of the outcome for one unit. Increase the predictor variable. An odds ratio greater than 1 indicates increased odds of the outcome, while the odds ratio less than 1 indicate the decrease odds outcome. P-values. P-values indicate the probability of observing the observed result. Next is evaluating model performance. Accuracy. The proportion of correctly classified instance precision. The proportion of correctly classified position instance among all instances classified as positive. Third is recall. The proportion of correctly classified positive instances among all actual positive instances. Next is Poisson regression. Modeling count data. First is count data. Poisson regression is used to model count data representing the number of events occurring within the specific time of or period or space. Second is assumption. The key assumption is the mean variance of the count data are equal. This assumption can be checked using various diagnosis tests. Third is application. Poisson regression is commonly used in healthcare, insurance, finance, and to analyze the event count like hospital admission, insurance claims, and stock claims. At last, you can see the example of Poisson regression on the PPT screen. On the left side, there is example in R. On the right side, there is an example of Python. So R in the R example, the R model GLM outcome predictor 1 plus predictor 2 data equal to data family equal to Poisson summary model. In Python example, Python from stat models or formula and the all outcomes are mentioned. So friends, if you like this video, please hit the like button, share this video, subscribe this channel. Thanks for watching the video.